Good afternoon. I was waiting for people to come in. People are over delaying. I think let's get started. So today I promised to introduce, good afternoon. I promised to introduce calculations on saturated vapor pressure and unsaturated vapor pressure. And in this case, what we are going to need is we are going to need one. These are going to be calculations. And these calculations are going to involve, they're going to be involving mixtures. And these mixtures will be for a vapor and a gas. So, case one, we can have a mixture of a gas, and unsaturated vapor. So for this first case, if you have a mixture of a gas and unsaturated vapor, if the pressure of the gas is Pg, this is the pressure of the gas, and then Pu is the pressure of the unsaturated vapor, pressure of unsaturated vapor. Then P can be the total pressure. Then from Dalton's law, remember from Dalton's law, when you have two gases that do not mix chemically, the sum of their pressures, individual pressures, is equal to the total pressure of the mixture of the two gases. So therefore, from Dalton's law, I expect that now people have read a lot about some of those items I'm mentioning. So you should have visited the internet, visited Nelcon, visited all the different books. You have the notes and read more about Dalton, so that by the time now I use it ahead, you know exactly what I'm talking about. That is how you need to read the physics. You don't just read notes and sit back. Read, do research, so that when you finish something totally, keep reading about it, confirm all avenues of reading. By the time they bring it again next time, you are an expert in that field. So, total pressure P is supposed to be equal to pressure Pu plus pressure Pg. There is one note we should have here. Note, in this case, both unsaturated vapor and the gas, these two obey gas what? Gas laws. Remember, we gave the difference between unsaturated vapor and the saturated vapor as for unsaturated being one that obeys what? Gas laws. While for saturated vapor, it does not obey what? Gas laws. So also those items, you should be having them nearby in your mind, so that when I mention them, you know what I'm talking about. So that is case one. So I can take you to case two. But before I can take you to case two, if they obey gas laws, remember from gas laws, PV over T is equal to what? A constant. That is in gas laws, if you recall. Now, if the volume is constant, so we can also say P over T is equal to what? A constant. Also, more so to that, we can also say, oh, PV is equal to a constant if the temperature is what? constant. So here in this case, V is a constant. Here in this case, T is what? Temperature is constant. So if the temperature is not changing, you know what is going to happen. If the volume is not changing, you should be in position to know what is going to happen. Then the second case, case 2. The first one was unsaturated vapor. Now, what if we have a saturated vapor and a gas? So this is a mixture of saturated vapor, and a gas. Now, if Pg is the pressure of the gas, is this one coming into this turbine network? If Pg is pressure of the gas, then Ps is going to be pressure of saturated what? Saturated vapor. Then the total pressure can be P. So for that reason, from Dalton's law, total pressure P is going to be equal to Ps plus Pg. But you should recall one thing. Saturated vapor do not obey what? Gas laws. So you can note and say, but saturated vapor do not obey gas laws. So if they do not obey gas laws, the gas laws only apply to the gas. Yeah? The gas laws only apply to the what? To the gas. And therefore, pressure of the gas can be got from the total pressure minus pressure of the saturated vapor. So this is the definition we can use in case we are looking at saturated what? Vapor. Then the other we can use it when you're looking at unsaturated what? Vapor. Any question on that? So we can have that down, then we take a look at an example. So I needed to first take you through those relationships because they are going to be very important when we are dealing with these calculations. So screenshot that. Okay. An example. Example 1. The total pressure in a closed vessel containing air and saturated vapor at 35 degrees Celsius is 1.01 times 10 to the power of 5 pascals. If the saturated vapor pressure, SVP means saturated vapor pressure, at 35 degrees Celsius, and 87 degrees Celsius, are 3.99 times 10 to the power 3 pascals, and 7.18 times 10 to the power 4 pascals. Calculate the total pressure at 87 degrees Celsius, assuming air remains saturated with vapor. Take that question down very fast. You can take a screenshot well and good. Jako emitwalo abiri. Jako emitwalo abiri kuno. Jako emitwalo abiri ku MTN. Ku MTN. Did you take that screenshot, guys? I'm very sorry. I had people who were disturbing me on a call, and I had to take their call. But I'm very, very sorry. But I don't know whether people have the number. Do you have the number? Or if not, I can resend it in the group. Then I can do the. I can do the what? I can do the solving here. Then you can have the question later. Had most people got the number? Yeah.
Yes, sir, we have it.
Okay. So if we have the number was saying at 35 degrees Celsius, we had total pressure as 1.01 times 10 to the power 5 pascals. Then we had saturated vapor pressure, which was 3.99 times 10 to the power 3 pascals. From the definition of total pressure P is given by saturated vapor pressure plus pressure due to the air or to the gas. Now, according to our situation, we have air. So I can say this is pressure of air, this is pressure of the saturated vapor. Now, I can get pressure of the air, and I call it, let's pressure of the air be P1. If I call it P1, I'll have total pressure, which is, this is total pressure PT, 1.01 times 10 to the power 5 is going to be equal to P1 plus the pressure, which is saturated vapor pressure, which is 3.99 times 10 to the power 3 pascals. When I make P1 the subject, can people compute and give me the answer?
97,010.
97,000. That is times 10 to the power 5
10.
pascals. Okay. So with that, we can get the other second consideration. At 87 degrees Celsius, what did the question say? At 87 degrees Celsius, we had a pressure of the saturated vapor pressure as 7 point what? 7.18 exponent. exponent 4. So at 87.1, we have the SVP, which is the saturated vapor pressure, which is pressure of the saturated vapor, was given as 7.18 times 10 to the power 4 pascals. In that case, they never gave us the total pressure. So PT prime is unknown. Then also, the pressure of the air. Can I check the total pressure at? We don't know the pressure of the air at that instant. Let me call it P2, because it wasn't given. But now, because they gave us the temperatures, if you convert the temperatures, one, we have a temperature of T1. T1 can be got from 273 plus 87. When you add those two, what do you get? We get 360 Kelvin. Then okay, let me call this one T2. Then the other one, call it T1, which was 273 plus, was it 35? What do we get?
300
308 Kelvin. Okay. Now, since a saturated, since air obeys gas laws, but saturated vapor does not. Since air obeys gas laws, the pressure initially P1 of air out of the temperature T1 is going to be equal to the pressure after at 87, yeah, out of the temperature at 87. Okay. So for that reason, we are looking for the pressure of the what? For the pressure of the air, which is in the second case, that is pressure P2. Therefore, P2 can be made the subject, and we say P2 is equal to P1 times P2 divided by T1. When you substitute, what is P1? P1 was 9.7 times 10 to the power 5 times the temperature T2, which is 360, divided by the initial temperature, which was 308. Can you press the calculator and get the answer?
$1.13 exponent 6.
1.13
1 exponent 6.
times 10 to the power 6 pascals. But the question wanted the total pressure at 87. Not so. So remember, total pressure is got from the pressure of the air plus the pressure due to saturated vapor what? Pressure. And in this case, total pressure shall be pressure P2 plus the pressure PS of our saturated vapor at 87 degrees what? Celsius. So total pressure shall give us 1.13 times 10 to the power 6 plus the saturated vapor pressure at that instant is 7.18 times 10 to the power 4. What is the total answer we get?
$1.20 exponent 6.
Wait, what did you get for this one? Was it exponent 6 or exponent 5? 1.13. Guys, press the calculator correctly. Oh, no. The first pressure was, how about this one? This one, was it the P1? Was it power 5, power 4? Someone compute that again. Check P1. Or P1 could be having a problem.
Teacher, it's to power 4.
Power 4, yeah, that's where the concern is. So change it. So this is power 4. When you change it to power 4, what do you get? This will be power 5. So if this is power 5, so this is also power 5.
$1.85 exponent 5.
Correct. 1.85 times 10 to the power 5 per square. That is our answer that we needed.
Sir,
Yes, please.
sir, I beg your pardon. Is that the, I beg your pardon, that is scripted network.
Beg your pardon, where? Yeah, from the beginning.
I had a scripted network.
And you pardon from the beginning or what? Or somewhere? Your network is funny. You know what? I'll save the video. You keep reminding me, I'll send it to you. Because it seems your network, because I hear the squeaking sound, that confirms unsaturated network. Let's have another example. So another example, question 2, it says, a volume of 4.0 times 10 to the power -3 meters cubed of air is saturated with water vapor. It's saturated with water vapor at 100 degrees Celsius. The air is cooled to 20 degrees Celsius at a constant pressure of 1.33 times 10 to the power 5 pascals. Calculate the volume. Calculate the volume of air after cooling if the saturated vapor pressure of water at 20 degrees Celsius is 2.3 times 10 to the power 3 pascals. Atmospheric pressure is equal to 1.0 times 10 to the power 5 Pascal. Take the screenshot. We there? So are we there? I want to rub off the other part. So I can rub off this side so that we remain with our question intact. So as you see the question, the question wants us to find the volume of air. But remember, air obeys gas laws. But for the saturated vapor, it does not obey gas laws. And remember, I showed you in the earlier definition when we are talking about, when I showed you the definitions of the calculations, we said if what? If we obey gas laws, then V out of T is equal to what? Constant. So at one point, we may need that equation, or we may need this one, PV. No, it's not about pressure, it is P out of T. Then the other one was PV is equal to what? A constant. Then the third one was PV over T is also equal to what? A constant for gas laws. Now, firstly, we have temperatures at 100 degrees Celsius. What is happening at 100 degrees Celsius? The volume of air is of air with saturated water vapor at 100 degrees Celsius is we have volume V1, which is 4.0 times 10 power negative 3 meters cubed. At that temperature T1, the temperature is supposed to be in Kelvin, which is 100 plus 273, and this will confirm 373. Then the saturated vapor pressure at that instant is what? Was it given? Yeah, it was given. The air is cooled to a temperature of 20 degrees Celsius at a constant pressure of 1.33 times 10 power 5. So SVP at this instant is 1.33 times 10 to the power 5 pascals. At the second temperature, the air is cooled at a constant pressure. It means that is the pressure we attained. So at the same instant, this pressure is still maintained here, which is the same as 1.33 times 10 to the power 5 pascals. The temperature in this case, T2, is going to be 20 plus 273, which will give us 293 Kelvin. And then we do not know the volume V2 at this instant. But at this instant, the saturated vapor pressure is, what? 2.3 at 20 times 10 to the power 3 pascals. And then they also gave us atmospheric pressure. That is ATM is equal to 10 times 10 to the power 5 Pascal. Now, from the definition of total pressure is equal to pressure of the air plus saturated vapor pressure. And in that case, the total pressure was 1.33 times 10 to the power 5. Is going to be equal to the pressure of the air, we can call it P1, plus the saturated vapor pressure, which is SVP. We can maintain this. Now, we need to have this note. I don't know whether I mentioned it earlier. At boiling point, the saturated vapor pressure is equal to the atmospheric pressure. So in case you get to know that we have a boiling point of a liquid, that boiling point at that instant, the pressure it exhibits is supposed to be equal to the same as the pressure, which is the atmospheric what? Pressure. So therefore, we now have our SVP as atmospheric pressure, which is 1.0 times 10 to the power 5 pascals. Therefore, pressure of the air P1 can be got from 1.33 times 10 to the power 5 minus 1.0 times 10 to the power 5 pascals. And the answer is going to be what? When you subtract these two, what do you get?
Three point three exponent 4.
Pascals. So that is the pressure of the air in the first case. Now, in the second case, that is case 2, still total pressure is equal to pressure of the air plus saturated vapor what? Pressure. Plus saturated vapor pressure. Now, in this case, the second case, they are telling us the saturated vapor pressure in that case is 2.3 exponent 3. While we don't have pressure P2, but we are having a constant what? A constant pressure of 1.33 exponent 5 as total pressure. So we shall have 1.33 exponent 5 is equal to P2 plus 2.3 times 10 to the power 5. Can someone deduce for me what P2 is?
Negative 9.7.
Are you sure it's negative?
4. Yes, teacher.
It's impossible. Hey, this is 2.3 exponent 3. Have you seen that? 2.3 exponent 3.
1.31 exponent 5.
1.31
exponent 5.
exponent 5 pascals. Now, remember I said, now in this case, you see everything is changing. Pressure is changing, volume is changing, temperature is changing, and the air obeys gas laws. So since the air obeys gas laws, we can say P1 V1 over T1 is going to be equal to P2 V2 over T2, and then we can deduce volume V2, whereby volume V2 can be given by P1 V1 T2 out of P2 T1. So this will become, what is our pressure P1? Our pressure P1 is 3.3 times 10 to the power 4 times the initial volume 4.0 times 10 to the power negativity of 3 times temperature T2, which was 293. All this divided by pressure P1, which was, P2, which we have got as 1.31 times 10 to the power 5 times temperature T1, whereby temperature T1 was what? Was 373 Kelvin. Press the answer, we get the solution.
Se- 7.15 exponent negative 4.
7 point, negative. Okay, 7.15.
7.915 exponent negative 4.
Are you sure? Someone else?
Same.
Same. Okay.
Yes.
7 point.
915.
8. Times 10 to the power negative
4.
meters cubed. Okay. So you can have that very fast so that I can look at an example of unsaturated vapor. But why don't I give you one and you try it now to test whether you are steady? Okay, I guess you're there. Let me do, okay, this third one. The other remaining two, you'll do them. I'm going to send them as assignments. But remember, guys, when we send assignments, they are not ours and they're not for fun. And if you don't do them, we don't make any loss, because for us, we did assignments in our time. Eh? So it's your job to solve your numbers. When we send the numbers, please endeavor to try them out. When you do a given concept, do a lot of reading and research on them as you personally. Me, I'm a sportsman, and I remember when I was at the club we could only train for 3 days, for only 2 hours every day. But what could make you an exceptional player is you to go back home on Sunday, on Saturday, on other days, evenings, work out extraordinarily hard, so that when you go back to the club, the coach can pick on you, seeing how fit you are. But if the coach cannot identify how fit you are and sees you are unfit, you'll always be dropped. The same knowledge applies here. If you just wait for coming here to class, after you close the books and wait for next Wednesday, my brother and sister who is out there, you are joking. This is called physics. Physics is the hardest in physical science. Biology is the hardest in biological science. So this is what makes you become a physical scientist. It is core. It is not any easy. You have to tail and tussle it out. Just like biology, where it is in the medical line. If you want to go for medicine, nursing, whatever, pharmacy, biology is key. So if you don't pass the biology, you can't go for any of those courses. Even here, if you don't pass the physics, forget engineering, forget surveying, forget IT, forget all those technological items or technological concepts would want to reach out. So we need to do extra load. Another number. Question 3. A closed vessel. A closed vessel contains a mixture of air and water, vapor, and in contact with the water. When I saw this number, I have to stop, because there is an Olympic match I have to watch, which is very sensitive, between Japan and Italy. Those are the greatest volleyball players we have. And since I'm a president of volleyball, you'll excuse me after this number. I wanted to stop at 5, but maybe I might not reach 5. I have to see how those people execute the projectiles. For those of us who have DSTV, you'll find it on channel 2 to I think 3. Then those of us with GoTV, you'll find it on channel 332. Max, exactly. So the total pressure in the vessel, at 27 degrees Celsius and 60 degrees Celsius, respectively, are 1.0 times 10 to the power 5 pascals and 1.3 times 10 to the power 5 pascals. If the saturated vapor pressure of water at 60 degrees Celsius is 2.0 times 10 to the power 4 pascals, what is its value? What is its value at 27 degrees Celsius? What is its value at 27 degrees slices. So as you've heard, we have 27 degrees Celsius. I can call this temperature T1. And with this as temperature T1, you convert the 27 to Kelvin, which will give us 300 what? Kelvin. Then we have the pressure, which is 1.0 times 10 to the power 5 pascals. Then we have SVP at this pressure, at this temperature, which is unknown. Then the second one is when we have a temperature of 60 degrees Celsius. The total pressure was given as 1.3 times 10 to the power 5 pascals. Then also they gave us SVP, which is 2.0. 2.0 times 10 to the power 4 pascals. Then we have the temperature T2 at 60 degrees Celsius plus 273 Kelvin. And this will give us 333. No. Is it 333? Yeah, 333 Kelvin. So now let's look at what the question wants. So the question wants us, for example, at 60 degrees Celsius, total pressure is equal to pressure of the air plus the saturated vapor what? Pressure. And for that reason, if that is the case, we can substitute total pressure, which is 1.3 times 10 to the power 5 is equal to the pressure of the air, which is PA, we don't know, plus the saturated vapor pressure, which was given as 2.0 times 10 to the power 4. This can give us pressure P1, which is going to be, when you subtract, what do you get? Let me call this pressure P1.
(1.1 exponent 5).
1.1 exponent 5 pascals. Then at 27 degrees Celsius, because they obey gas laws, we can have the air obeys gas laws, we can have pressure P1 out of temperature T1 is equal to pressure P2 out of temperature T2. So they're asking us for the value of the pressure at 27 degrees Celsius. So we shall have at P1, we have seen P1 is occurring at what temperature? P1 is 1.1 times 10 to the power 5. It occurs at a temperature of 333 Kelvin. It's going to be equal to P2, which occurs at a temperature of 300. Can we get P2? This P2 is the pressure of the air at 27. So this is pressure of the air at 27 degrees what? Celsius. So when you get the pressure at 27 for the air, you go back for the total pressure at 27. Total pressure at 27 is going to be equal to pressure of the air plus SVP. And we are looking for SVP at 27. So we can make SVP at 27 the subject, which can be got from total pressure minus pressure of the air. What pressure do you get? Someone has it in the chat. $9.999 times 10 to the power 4, correct, pascals. So when you come here, we shall have total pressure in case 1 at 27 was 1.0 times 10 to the power 5 minus 9.01 times 10 to the power 4. So what do we get? Answer?
Nine 9.9 times 10 exponent 3.
Eh?
9.9.
Are you sure 9.9? No. Sorry, this was supposed to be 9.91. Because it was 9.91 down here. I wrote 9.01, so that makes it a change value. So this is, now it becomes what? 9 point?
Just 9 exponent 2.
Exponent 2. And that is the answer. Okay, so next time you need to read about boiling and evaporation. These are detailed, just like we started with saturated vapor pressure and unsaturated vapor pressure. They require you to know the science, the physics behind it. So I will also require you to read a lot about boiling and evaporation so that you can get to know the science behind by the time we come for the discussion, when you have a brief idea about it. Read about the factors affecting boiling, factors that can affect evaporation. Read about kinetic theory explanation, how boiling occurs. Because these are examinable, they are very common questions. Explain how, using the kinetic theory, how boiling of a liquid takes place. You just said the liquid blah 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 boils. You need to tell us. It's just that my studio is in my sitting room. I would have showed. I will see if I can display some boiling outside, or I'll bring my gas stove here and we display some boiling so that you get to see what is actually happening when boiling is taking place. But what I want from you is to go and read. Explain the temperature, how boiling, what the boiling point temperature, why it occurs at that temperature, what pressure occurs there. Use the kinetic theory to explain. I just want you to read about them. Then when you come back, we shall be in position to have this handled. So sorry, I have to go off and take this call. Like I said, I will not reach 5 because there is a gentleman I sent to the medical store. He has to buy medicines for my animals. Any further questions, please consult me in my box. If there is someone new, then 0782 855 674 is my WhatsApp line for help. Otherwise, with that, we can call it a day. We meet tomorrow for modern physics. I don't remember though where we stopped. Please inbox me because we've taken some good time without handling modern physics.